Okay, so what in your mind, okay, what was the toughest part about the materials that we've done so far? As far as Friday goes, that's all problems, but there's no dot diagrams on it. Okay, we evaluate you on that. Okay, and plus they're time consuming, and if you look at them long enough, you start to go cross-eyed. You don't need to do that anymore. I know, right? Yeah. And some of you will be seeing that again in general chemistry in 2 years. So what we want to talk about now is for part B or part 2, which is on Friday. There you are naming compounds and you're writing out the formula and then adding together the atomic mass. Again, it sounds like it should be something that is so simple, but yet it's easy to make mistakes. I still make mistakes. It's easy to do. And what do we always say about mistakes?
Happy little accidents.
I don't know about that. Maybe.
We're also painter.
Oh, yeah. Okay. Have the brown curly hair.
Yeah.
Make a happy little tree.
Happy little tree. Happy little
Yes.
accident.
Didn't we
Beat the devil
say,
out of it.
1, you want to learn from mistakes, and 2, try not to what?
Make them
Try
again.
not to repeat them. That's right. Okay? In other words, you know, if like there's a hammer laying around, you don't pick up the hammer and hit yourself in the head, that would be a mistake. So then you're learning from that, you're just not going to repeat that. Unless you want to go to the other side to balance out the fraction on that side. Yeah. Okay. So let's test your chemical or chemistry intuition here. Okay? We made up a disaccharide this morning. It doesn't exist. Okay? One of the things that some of you, if you decide to go on to take organic and biochemistry, it would involve something like this. So, for instance, what I want you to do, you won't see anything this complex on your exam on Friday. But what I would like to think you could do is calculate the atomic mass of this in the red. Okay?
Those carbon.
Those are carbon atoms. Okay? So again, it's one of the things that I think it's important to kind of raising the bar here a little bit and to accomplish that. We want to give you something challenging, but yet work on it together so we're very comfortable in, let's say, accomplishing those tasks. So rather than listening to me, someone can volunteer to come up here and calculate that. Get in on this option. Going once. Going twice. Not so long. You gotta get tired of listening to myself every day.
It's actually kind of fun.
It's gotta be mind numbing.
No?
We don't.
Well, we tried to multiply the voice, so it's
You
not
can't
so
make
much.
the jokes that used to make.
The one way.
They just happen automatic.
Awesome.
Well, I'm always a leg up on things. See?
Oh, there's
See?
carbon.
That's all.
Just comes naturally.
It's total funny. Okay. Okay. So, what do we see? How many carbon atoms do you see total?
5.
4, 6.
What about the top?
Okay.
And the bottom two.
Yeah, the bottom 2.
All right. How many hydrogens do you see?
11.
Close. Got the top one.
12.
Okay. How many oxygens do you see?
5. 6.
Okay. Now, what's so significant about this? This is something that you've seen over and over and over, but you never really knew how that applied to what you've learned. Can be. You're exactly right. It can be. All right. So what I mean by this is trees cannot be doing this right now. Pine trees can, because those are gymnosperms. Say that again. Yes, because deciduous trees do not have leaves yet. So without having leaves, they can't perform this function. Photosynthesis, where you're younger, you're closer to their generation than I am. What does that mean?
SpongeBob.
What?
SpongeBob.
Yeah.
Does that make sense to you?
Look it up.
It doesn't make sense.
Look up photosynthesis.
Well, he's got me.
Yeah.
He uses his legs.
Yeah.
He's way more
Oh, okay. I never would have guessed.
All the way. Yeah. What a guy.
Photosynthesis, cha 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 cha. Photosynthesis, cha cha cha. All right, we move on. Anyway, so yes, the sunshine is coming down, the leaves absorb it, and the roots take in the water. They shoot the water through the root system up through the stems into the leaves where it meets the sunlight, and a chemical process creates photosynthesis and sugars in the form of glucose. But neither one of these are glucose atoms because this is actually an isomer of what you see down there. This is what we call mannose, and this is another sugar called altrose, I believe. And there again, that doesn't mean anything to you right now, but some of you who do want to go into an advanced science field, which could be nursing, could be medical school, could be pharmacology, any one of those, you would be encountering something like this. The reason we call this an isomer is because these have the exact same molecular formula, but do these look like the same structure, the green and the blue? Yeah. No. No. And the clue is these guys right here. What do you notice about these OHs? They're pointing up as opposed to over there. One of them is doing what? This guy right here is pointing down. Okay. So what happens is how these are oriented changes the chemical properties of this. Anyway, so we bored you enough with that. See, if one of you would have volunteered, you wouldn't have to listen to that garbage. But no one volunteered. But then you might not have been see the square pants. Not square pants. Okay, I got one. Anyway. So each carbon atom has a mass of what? 14? No. Okay, 12.01 times what? Okay. Okay, hydrogen has a mass of what? Okay, and each oxygen atom has a mass of what? Okay. I can't add that fast. I've just seen this so many times that you get to memorize those from time to time. Because you don't want to admit it, because I'm willing to bet you people won't, is that some of you are starting to memorize that periodic table. Not because you were told to, but you've been exposed to it enough that you're starting to memorize parts of it. Which is okay, right? Yeah, because as we look at the time right now, it looks like it is sodium copper. Is it? What's the atomic number for sodium? 11. What's the atomic number for copper? 9. Hey, what? We got 1129. Just think of how smart you can sound if you start telling time by the periodic table. Start speaking in code. Yes.
I'm sure that's what you do over ORR. I mean, Java.
We're smart.
People need that. I don't know.
Never know the next dumb thing that comes out of this mouth. Okay, so does this make sense? You're just taking the atomic mass of each element times how many you have and just doing that simple math. Okay. Again, one of the things we've talked about, you've been doing solving algebraically points on a line or solving for volumes and what else might you areas. That when you're using these equations, you're using higher order thinking that sometimes with some of this, it's not that you're bad at it, you just haven't been exposed to it for a little while. Okay, so can I erase this? Okay. So just keep in mind that part 1 tomorrow is vocabulary and some of the questions that you may have seen on here. Okay? And then part 2 would be what we just went over now. Okay, so someone give me a transition metal, please. Okay. And give me a halogen, please. Okay. So let's see here. What is going to happen?
+6, +4, +2, -2.
Okay, so pick one of those. Okay. So if we needed to write out the name of what that chemical formula is, I probably should ask, is this a symbol for tellurium? Okay. So what would you do next? Of course, you're going to look at element number 52. Okay, 52. So for tellurium, so we have this. Is there 2 L's?
Yeah. You are.
No, you are. Oh, you people aren't here. You're missing out. I gotta ask. Some of you go home. See what we got to put up with every day. Listen to this garbage.
Awesome. Great.
Well, otherwise, your parents might say, "We want to take this class. It sounds like it's fun." Oh, I suppose I need to pay you after class for saying that. Okay, fair enough. Okay, so here's tellurium. So chlorine is a molecule if it's neutral, but now it's been ionized, so it's not tellurium chlorine, tellurium chloride. But do we need to put a space after this?
Yeah.
Yes, we do. Okay, but this was just an example. So how can we determine which tellurium we're talking about? We always say start with which ion? The negative ion. And the chloride ion has a charge of negative what? Okay, and we've got 4 of them. So the negative side has a charge of negative 4. And this tellurium has to have a charge of what to add up to 0? And it can do that according to the chart over there. So the last thing, or on the wall, excuse me, the last thing we need to do is decipher which tellurium we're talking about, and the Roman numeral is which one. Okay? Tellurium 4.
The
Okay?
table you gave us only has +4.
Yeah, that on the wall, it's a little more, I won't say detailed, I won't call it that. So it's a little older, okay? When I look at that, that probably came out the same year that a lot of your parents may have been in perhaps elementary school and some in high school. Okay, 1991. Just write that year backwards. Yeah. It's a palindrome.
Race car.
Yeah.
Taco cat.
I believe you. Then the last thing we need to do is add together the atomic masses. So, tellurium has an atomic mass of what? Well, it's right next to iodine. Okay, so 127. Only reason we knew that is iodine's got an atomic mass of 126. This is where it's kind of a little, if you're going by atomic masses, this would be out of place. So 127 for the tellurium. What is one chloride ion's atomic mass? 35.45. And how many do we have? So that 35.45 times 4 is 141.80. So approximately, okay, approximately 328. Okay, and just remind me, make sure I get these papers handed back to you.
Wait, that's not right. It's 268.
Oh, I was thinking this was 12 added together. But I was just making sure you people were paying attention. That's right. 268. Okay. So then the last thing that we want to do is if we see something like this, okay? Notice when we're doing these really difficult ones, we are working on them together. So those of you following along, it's really going to help you out in the long run. Okay, so tungsten 6 carbonate. Okay, so the symbol for tungsten, as you said, is on 74, right? Okay, and again, a lot of you become more and more familiar with this periodic table the more you use it. So the symbol for tungsten is W. Okay, and the formula or symbol for the carbonate ion is what? CO3. Okay, so start by your negative ion. Carbonate has a charge of negative. Okay, got -2. So remember, this is one carbonate ion. And it's got a charge of -2. The tungsten, we don't have to guess. It's telling us what the charge of tungsten is, which is +6. Okay? And again, that's over on that wall, that periodic table. Do these charges add up to 0? No. Right now, we've got one tungsten atom and one carbonate atom. The charges don't add up to 0. So what's the least common multiple between 6 and 2? It is 6. That's right. Okay? And it's just human nature. We're saying this is where we want to learn from these mistakes. People still do this. They're looking at that and saying we must have to have 6 of them. Now you have an overall charge of positive what? 36. So we don't want to be doing that. Okay. So the least common multiple was 6. 6 divided by 2 is what? 6 divided by 6? 1. And that's what we've got. Okay. last thing, let's add together these atomic masses. Tungsten has a mass of what? Now, here's the tricky part. One carbon atom has a mass of what? 12.01. And how many of them do we have? 3. So we got to take 12.01 times what? Okay. Now, inside these parentheses, okay, one oxygen atom has a mass of what? 16. But we've got 3 of them, okay? But what do we got to do with these 2 3s together? Multiply. So 3 times 3, 9. 9 times 16, 144. Okay, so 8, okay, 11, 1, 18, okay. You get 364? Okay. And it's kind of funny, and just please laugh at yourself. It's easy to make these mistakes. We look at them and say, just simple addition. But it's easy, again, it's easy to make those mistakes. For those of you working on those woodworking projects, okay, you might want, if you're making a piece of cabinetry, and do you think you'd want to start making your project out of oak plywood right away? Probably not. Why might you not want to do that? Because what do you suppose oak is as far as pricing? It's expensive. Okay? So we look at this sheet of plywood that this came from, thanks to Coleman Building Center. Okay? A 4x8 sheet of plywood is probably somewhere around $65. Okay? Because it's got one nice side to it. It's got a sanded finish. Okay? You don't have to you don't have to buy plywood like that. You can get it where it's unfinished and it's rough on both sides. It's a little cheaper. But if you want it to really look nice, you get it where it's sanded down on one side. Oak plywood in this size would probably be $90 maybe for that same sheet, just because it's made out of oak instead. So the reason we don't want to make those mistakes on that expensive piece of hardware or okay. I'm not going to stand up here and bore you to death with writing these chemical formulas and adding together the atomic masses. If we want more, we can do more examples. But if you're telling me that you understand, but you really don't, please take the initiative to get in and talk to myself before Friday. Doesn't help. If the cattle are already running across the road and the gate was open, does it make any sense to close the gate while the cattle are still out? No, it doesn't. Well, true. Extenuating circumstances. So, right outside, are we good? When you're nodding your head, you're telling me that you're understanding this. Okay, left middle. Okay. I didn't ask yet. See, we're just seeing if we're paying attention. Left outside. See how mean that is? Right middle. And then middle. All right. Anything else? Oh, how soon we forget. That's all we can say. I could. Okay. An example of that would be, for instance, what that means is for every molecule of iron 3 chloride, there's 6 molecules of water locked up in there. That's all that means. Hydrate. What does it mean to stay hydrated. This is filled with, you think, water. Oh, I'm being mean. Okay. Yeah, it's filled with water. So you want to stay hydrated. So when we're talking about a hydrate, that means all these water molecules are locked in with that iron 3 chloride. That's what a hydrate is. Anything else?
Is it good?
It is. That's right. This is Copenhagen water. Good stuff, right? Yep. Well, at least it's not water all around and not a drop to drink. You ever heard that before? If you're stranded at sea, you'd be saying that. You're in the middle of the ocean, you can't drink it. Unless you let the water evaporate and let it condense and collect it against all the salt leaves. Yeah. You're in the middle of the ocean, you can't drink ocean water. You got all of that, you can't drink it.
The salt. Yeah.
Okay. Anything else? Again, the clue is, oh, how soon we forget. You're gonna think, God, I forgot. Now I remember.
Tomorrow.
True.
Is our quiz on this or is that on Friday?
This part's on Friday. But there could be questions like, which one of the following is the correct formula for iron chloride? You have a multiple choice. Nothing else? What was that?
Yep. Nothing else.
Oh, I thought you said what we were looking for. My tune's going fast. Starts with a B and ends with an S. BS, I know. So,
Boron.
say that again? No.
Boron sulfate.
Oh.
I like that.
Okay.
Oh.
Okay.
It's a bonus one.
Why can't they get rid of that?
Yes.
I can't remember if this is plural. Okay, so baseball has triple crown winners, means they have the highest batting average, the most home runs, and the most runs batted in. That's a triple crown winner. It comes from this, talking about horses. If they won the 3 big races, the Kentucky Derby, Preakness, and the blank state. If they win all 3 of those, that is a horse who has won the Triple Crown. Okay. Is it the glare or is it the marker? Or? Okay. All right. Fair enough. Who might come to mind as far as singing in country music? First thing that comes to your mind.
Georgia.
Okay. Can be. Not who I would have thought of, but for country music groups, singers, artists, whatever you want to call it. Is that my computer? Or yours? Okay. So when singers, we're talking about country music. If they perform at the Ryman Auditorium, it is also called the blank. So, kind of like you go up to SDSU, yes, you're going to the Hyper Center, which is the whole building. But if you're going to watch a basketball game, you're actually going to blank. What arena? Frost Arena. So this is kind of like what we're talking about. The Ryman Auditorium, you could say it's kind of like the whole building, but country music artists perform on this stage. And it's the blank. You kind of go hand in hand, kind of like Hyper Center and Frost Arena. All right. So you've got a few minutes left, and the rest of the time then is yours.